Hello, everyone. Thank you for joining us. Today, we are excited to unveil GeoCue's latest addition to the TrueView 3D Imaging System product series, TrueView 515. Before we get started, I would like to go ahead and do an audio check. Please notice the raise your hand button has been circled in red on the slide. If you can hear me, please click this button now. And we still have a few people joining us, so I'm going to give everybody a few seconds to go ahead and raise those hands. We have a big crowd with us today, so welcome. All right. Looks like everyone can hear me. My name is Crystal Bailey, and I will be moderating today's session. Joining me is GeoCue's President and CTO, Louis Graham, and Senior Business Consultant, Madeline McNabb, as well as VP of Special Projects, Martin Flood. He will be answering questions during the webinar. Before we begin, I would like to go over a few things. Group audio has been disabled for this session. If you would like to ask a question, please use the question box on your GoToWebinar panel. This session will be roughly 60 minutes. If we do not get to your question during this webinar, we will follow up with you by email. This webinar is being recorded and will be distributed to everyone registered. At this time, I will be launching one poll question to get us started. Please indicate your use of drone mapping/inspection technology. Check all that apply. And this is a question we usually start off our webinars with just to get a good idea of the user group that's with us. So I'll go ahead and share those results once everybody's done voting. Leave this open for a few more seconds. All right, go ahead and close that poll and share those results with everybody. Looks like we have a large number performing photogrammetric mapping using drones. Well, thank you for participating in that poll for us. Joining me now is GeoCue's President and CTO, Mr. Louis Graham, and I will hand over the presentation to him now.
All right, can you see my screen, Crystal?
I can.
Well, hello, everybody. Thanks a lot for taking an hour of your time to attend this webinar. You know, usually these reveal webinars, we're bringing a new sensor to market are 90 minutes, but I think we got feedback that is a little bit too long, so we're going to cram a lot in the next 55 minutes or so. A quick overview of our company. We founded the company in 2003. Our headquarters is in Huntsville, Alabama. We have an office in Toronto, Canada, and we just formed a joint venture company in Brisbane, Australia. So we've got a multi-person office in Brisbane headed up by Mark Hickey, and he's forming a branch office in Perth. So I guess we're a LiDAR world. Our focus in this company is in three major areas. So when we started the company, our focus was on airborne laser scanning and mobile laser scanning in manned aircraft and vehicles. And we continue that to this day. We're North America's support center for the TerraSolid product family. We have our own product, LP360, a desktop exploitation tool. We do a lot of data management, workflow consulting in that area. And we also have an enterprise solutions group that does custom software on a larger scale. So for example, we have a contract with Teledyne Technologies to do processing of a hyperspectral camera. We do a lot of work with the U.S. Department of Agriculture on LiDAR QA, QC processes and technology related to that. But you do see this common theme of LiDAR. We started looking at drone mapping in 2012. It went through a lot of evolutions with different kinds of technologies and approaches. And 2 years ago, we introduced our TrueView sensor product line, which has really been successful. And that's what we're here to talk about today. So we've done over 3,500 drone mapping projects. It's probably more like 4,000. We fly multiple times per day when we're testing systems, calibrating sensors and so forth. And we still engage quite a bit in research projects with customers. You know, how do I do a certain kind of LiDAR or camera type technology? We sell throughout the world. We sell direct in the U.S., except the southeast of the U.S., where Earl Dudley in Birmingham, Alabama, is our premier reseller. And of course, we have our own offices in Australia and Canada. And then we sell through a series of resellers in other countries. We've got a nice building customer base of the TrueView product line that ranges from small engineering firms to major large engineering firms, as well as departments of transportation and government agencies. So a really good cross section. The common theme is companies and agencies that have to do high accuracy, what we call metric mapping. So what is a 3D imaging sensor? So an airborne LiDAR on a drone is really nice, and here's an example from a 515, what you would consider traditional LiDAR. So I've got a color by elevation view. You can nicely see the wires, the vegetation. Colors represent the height above, in this case, ground probably, or ellipsoid. But if we add color, you know, it changes the nature of the data completely. So this is what we do is something new. You know, colorizing from an ortho is that's been going on for a while, but our colorization is done from integrated cameras, and we'll talk a lot about that and what it means to you and what it means in terms of data accuracy and fidelity. And this is what we call 3D imaging systems. So when you hear us say 3DIS, we're talking about LiDAR for the elevation data, cameras for the colorization. Here's a side-by-side comparison. Same sensor, one is colored by elevation, the other is colored by RGB. And the information that is present in the right-hand image is just so much more, orders of magnitude above just viewing by elevation or just viewing by intensity. It really aids in many different things, from inspection and so forth, but mainly identification. You know, if I'm going to classify LiDAR data, it'd be nice to know what it is. So the new sensor we're talking about today, the TrueView 515, really rounds out our product offering. On the high end, we have the premier RIEGL-based 6XX series of sensors ranging from 615 to 640. These are all based on the RIEGL MiniVux, and I think everyone who knows anything about LiDAR agrees that RIEGL defines I guess the ultimate in survey accuracy in this business. And then the first sensor that we built in the bottom of the pane is the TrueView 410. That's been on the market for about a year and a half now. Very popular sensor, does a fantastic job. It's a really nice go-to sensor. And then today we're talking about a new sensor, the TrueView 515. So that's the star of today's show. But just bear in mind, we do have these other ones. So we have the 410, great general purpose sensor. We have the RIEGL, great survey grade instrument. But I wanted something in between. You know, we needed something that was better at dense vegetation and wire collection. So we have a lot of surveyors and data collectors who reserve the RIEGL class systems for, say, Department of Transportation work. They wanted a general purpose sensor for wire and vegetation. And the problem that we had with this was that every sensor that we looked at that could offer high density and decent range was too noisy. It's just, you know, just terrible looking data. So we had been postponing on this sensor and doing a lot of testing on, you know, what would meet the specs that we were after. And we finally settled on the Pandar XT32 from Husai. So this is a 640 kilohertz dual return system. So it puts a lot of points out there, and it's got great sensitivity. So we're really impressed with the sensitivity of this. Other than the sensor, this configuration is the same as the configuration of the TrueView 410. I was going to go through and show you every circuit on the CPU, but Madeline kind of prompted me and said that might not be something that everybody's interested in. So we'll look at a higher level of that. We've recently released an M300 mount, so we have mounts available off the shelf for the M300 as well as the M600 for flying this new 515 sensor. We can accommodate others as well, and we'll talk about that. So we will cover a couple of components of this system. The laser scanner, again, it's the Pandar XT32, and this means it's putting out 32 beams. So in this lower right image, you can see one rotation of that scanner. So you can see the footprint that it puts on the ground, and of course we're flying at a nominal 5 meters per second. So we'll move forward a little bit and sweep that area again. So you can see it's putting a lot of points on the ground over an approximate 30-degree field of view in the in-track direction. It is dual return, and it's got really nice reflectance. So it does a scheme of 8-bit scaling of the percentage reflectance that it's seeing, which comes down to a granularity of about a third of a percent per step. So good grayscale imagery from this scanner. Same dual mapping cameras that we've had on the 410 and that we have on the 6XX series. These are custom built for us, and they're photogrammetric cameras. They're not just, glommed on DLSR cameras. They're designed for photogrammetric mapping. And what does that mean? Well, it means, first of all, that they have to have a mechanical shutter. And of course, many DLSR cameras have mechanical shutter. But these have electronic mid-exposure pulse, what's called a MEP. And this allows us to synchronize the camera precisely with the position and orientation system. Without that very tight synchronization, we would not be able to do the point colorization that we do in 3D, in our 3DIS scheme. It also has fixed focus lens, and what that means is that it will hold calibration from flight to flight. If you have any kind of focus ring on a camera, it's very difficult to keep consistent calibration. As you rotate the lens, it changes the principal point intersection with the sensor and so forth. And of course, we continue to use the Planck series of position and orientation system. This market is becoming more crowded. There are a lot of options. But we have a solid track record with the Trimble equipment. It just works, and it does, a fantastic job of positioning as well as determination of orientation. So we're very happy with these solutions. One of the tricks to being able to do a 3D imaging sensor is that you have to be able to simultaneously calibrate three things, and that is the laser scanner, the body frame of the system, including the Planck's position orientation system, and then the camera. So everything has to be in a very rigid system. You fly it multiple times, you land, you put it in the carrying case, all these different things, and it has to maintain that alignment. That's pretty difficult to achieve, but we've managed to do that through the techniques that we use with aluminum and rigid mounting. And this has turned out quite nice, and it makes our ray tracing colorization possible. And then we move the controls of the LiDAR system to the top of the drone, so you don't have to bend over trying to look underneath the drone. We've got a nice controller. For you guys with 410s, we've upgraded the controller. I think some of them we've already sent to you. But we've now got an LCD readout that gives you a couple lines of text to tell you what the sensor is doing as it's booting up or after it lands and it's copying images and so forth. So you don't have to just sit there looking at a blinking light. It gives you a little more information than that. Of course, all information is recorded to a USB memory stick that plugs into the sensor, and that makes it really convenient for moving data from sensor to the PC. So overall specifications for this system, range is really, it's a hard number to give you. I'm going to say this is a general purpose 90-meter sensor, but it depends on what you're flying. If you're going to fly a coal pile, you're going to want to fly a little bit lower. If you're doing just topo of a vegetated area, you can probably fly a little bit higher, but we have to pick a number, and so I'll pick 90 for this. I think is a good general purpose number. We have a cross-track field of view of 120 degrees, and that includes the imagery data. So a lot of times if you buy a LiDAR and they glom on a DLSR camera, you might get a 45-degree or 50-degree or maybe 60-degree view out of that camera, depending on the lens that you've used. And so you have to do different flights for the image data than you do with the LiDAR. you usually have to make more flights with the image data. And of course, we use dual cameras to do that. Some others will put two DLSRs in a V-type configuration, similar to what we do. But then again, you've got a synchronization and calibration problem, but you also have an awful lot of weight. Those really aren't mapping cameras. So I think it's really important. Our cameras make a huge difference and really differentiate the difference between just an airborne LiDAR and a 3D imaging system. I'm saying the specs right now on the sensor are 5 centimeters root mean squared error for network accuracy and precision 5 centimeters. And those of you who have looked at the 410 will note that those are the same specs that we have for the 410. That's pretty remarkable with the 32 beam sensor. You know, usually if you do something like you have an 8 beam, say general purpose scanner, and then you go to a 32 beam for high density work, you have to sacrifice quite a bit of noise or quite a bit of precision in that process. But this sensor holds up well in that evaluation criteria. And it comes in at 2.2 kilograms, almost exactly the same mass as the TrueView 410. One of the big deals we have is the processing software. So we don't just get you to point cloud LiDAR data, you know, we get you to products, and we get you there, I think, efficiently, intuitively, you know, in a way that makes sense and is easy to do processing. We have cloud components as well as desktop components. And one of the, I think I would call it business criteria that we always maintain is that if you buy a sensor from us, you do not have to pay for any cloud processing. So we're not trying to kind of mold the two together. Yeah, there are cloud options, but they are options that, you know, if you want to make use of them, you can, and they can come in handy, but they're not necessary for getting products out the door. Something we do with the cloud, which has really improved the reliability of our sensors, is that we track a lot of sensor parameters in flight: temperature, currents, voltages, what's happening with the cameras, what's happening with the laser scanner, and so forth. And those log files are sent to our cloud processing system that does an analysis, and if it finds an anomaly, it automatically notifies our support group, and then they can take proactive action with you. And sometimes it's as simple as, you know, we know that a USB stick, for example, should be reformatted because it's slowing down because of fragmentation of the data on the stick. TrueView Evo and POSPAC come with our sensors. Evo is the desktop processing software that takes you from import of LiDAR data all the way out to final products. The nice thing about TrueView systems is that all sensors use identical workflows. So you use the same steps in processing. If you're going to do exploitation of the data, it's exactly the same tools. And this even includes our guest sensor. So our first guest sensor was the Phantom 4 Pro RTK. We're just now testing and adding the M300 with the new DJI P1 camera. So that's on the photogrammetry side. And of course, we have our own TrueView 250 on the photogrammetry side as well. So this is an important thing because a lot of you guys will have multiple sensors. You'll use photogrammetry for, you know, quick bare earth type jobs, LiDAR for other jobs. To have unified training and unified software really makes things go a lot faster, a lot smoother. So I'll give you a quick view of how processing goes in TrueView Evo. We have a wizard is the first thing that is encountered by the user. We've added some things that can be helpful, such as the ability to directly archive data when you bring it in, so you can compress the data or we compress the data for you as an entire package and store it on a network drive that you've designated as your archive. So that gives you a nice backup copy of the data. If you want to, you can also post it to our TrueView Reckon portal, so you can store it in Amazon Web Services if you want. If you don't want to have to worry about who's going to do my backups and those kinds of things. As soon as you import the data, so that's answering a few questions about where you're importing from, and you click OK, you get an immediate view of the project itself. So you get a 1 second heartbeat GNSS track, as you can see in orange on this image. It shows you, you know, where you've flown, the coverage you have, and so forth. So it's a nice visual ID of what's going on. The photos are an integral part of this right from the beginning. So you can click on one of the dots. It will show you the photos that were taken at that camera station. And you can see that view presented here. And of course, we have a port and starboard or a left and right camera. So we have two views per camera station. We've integrated a Planix Pos Pack. So that's the software for processing the raw GNSS and gyro observations or inertial navigation system observations into a computed accurate trajectory. That process can be a little bit intimidating when you run POSPAC desktop, and so we've integrated that directly into Evo. We drive it through a script that was developed by Planix for use of remote processing. And it works quite nicely. So we pick up a lot of the information that was imported when you did the import of the project and automatically populate these dialogues. Another really nice thing that we've added within TrueView Evo is that if you want to use Trimble PPRTX or a Planix Smart Base, you can do that without the need to have an annual subscription for those services. You can pay by the minute from this interface. So that's really nice. And so, for example, if you were using a local base station, something went haywire and you don't have an available local core station to do processing, you might want to process via PPRTX. We have tools that generate flight lines for you. They can be done automatically. You can also go manually edit them. And what this means is that what we're really interested in processing in the LiDAR and image data are these blue lines, and the green lines represent the entire flight as well as some takeoff, landing over in this area. And I don't really want to process all that. So it's a nice cleanup tool that gives you clean flight lines for processing. And then of course it's geocoding the LiDAR data. So that's just push button. Process these data. Something else we do is that we store calibration for your system in the TrueView Reckon Cloud data management system. So you always get the right calibration file, even if you're flying a whole family of sensors. That also includes Phantom 4 or any guest sensors also managed within Reckon. So that really makes it nice, because one of the more common and hard to debug problems is using the wrong calibration file with the sensor. That can be a kind of a configuration management nightmare. So we've taken care of that for you. After you run geocoding of the LiDAR data, then you get a traditional LiDAR point cloud, and it's loaded directly into Evo, ready for whatever exploitation you're going to do. So at this point, you've got data that you would see from common airborne UAV LiDAR systems. But we add the colorization step to this. So this is just a click of a button. Yes, I do want to colorize. I can't imagine why you would not want to do this step. And when you run this step, we trace every individual point in the LiDAR data up to the original source image. So we don't interpolate from an ortho photo. We go back to the original source images. We pick the best image, and then we colorize the LiDAR data from it. And you wind up with these beautiful colorized pure 3D point clouds. So they have very high metric accuracy, and now they have very high radiometric accuracy as well. So a new type data. Now, you may look at a lot of systems when you're deciding what system you want to purchase. And I think other than our TrueView systems, everybody else does colorization from a ortho photo. So you'll go fly the system with or without an attached camera. If you have an attached camera, maybe you can do the flights all in one. Then you'll take the image data through a photogrammetric workflow, create an ortho with that data, and then take that into some other process, maybe a global mapper, our own LP360, and colorize the point cloud data from the ortho. And that's not the same at all as what we do in 3D imaging. So on the left is LiDAR point cloud from the TrueView 515 colored from an ortho photo that we created in the process that I just described. On the right, we have a true colorized 515 set of data. And you can see a dramatic difference in this because in colorizing from an ortho for any XY location, you can only use one color point out of an ortho photo. So if you have vertical changes, you won't pick those up in that colorization. You can see that pretty dramatically here. So in the true data, the 3D IS data, you can see there's a service door on each side of this high bay door, painted red. They're not even visible in this data colored by ortho. You can see this red trim along the roof, and over here you can see an occasional place where the red trim was just pushed all the way down the side of this building. That's particularly prevalent over here on the right side of the image. So there's a huge distinction between the two, and it really makes a big difference when you're doing wire extraction, when you're looking at utility poles and that sort of thing, to use 3DIS data instead of just LiDAR data. TrueView Evo, the software that comes with the sensor, it's a very rich environment that of course includes all of the post-processing that's necessary to go from a TrueView imaging system into a colorized point cloud, but we also have quite a few tools beyond that, such as automatic ground classification. We have accuracy measurement tools that are ASPRS compliant and will generate accuracy reports if you need to deliver those with your data, all the way to automatic rail, automatic wire extraction. Wire extraction, by the way, for you guys that are already using Evo, it's already in the software and experimental version, and that should be finalized in March. So a really nice new addition to TrueView Evo. Something else we're bringing to market within the next 60 days, I would say, is Evo Explorer. So this is a viewer based on Evo that allows for visualization of data and basic measurement of data. So you can't go make products with it or do classification, that sort of thing, but you can do a lot of exploring of data that's already been processed. So this is a free viewer. You can give it to your customers. And we're building a new export package that will let you take a TrueView Evo project and export the LiDAR data as well as all of the individual images. So not photogrammetric processed ortho photos, but the actual images that were, individual camera images. And we've added algorithms that will let you click on a point in the 3D data and it will show you what images are seeing that 3D point. So this is really great. It's very valuable for inspection type operations. If you're looking, say, at power lines, you want to know what's attached to a pole, you can click on a laser point, you can look at the images, and you can see in detail what's going on. So we've implemented that by adding the idea of what we call true pose images. So these are images that have full calibration data, XYZ and orientation information stored in the so-called EXIF data of the image. So no other data needed, just LiDAR data and these images. Another little bonus, not related to the TrueView 515, but it is of interest because so many of you are doing photogrammetry, is that with the March release, PPK processing for the Phantom 4 RTK as well as the P1, the new P1 camera from DJI, is supported in TrueView Evo. So if you bought an Evo sensor from us, a 3D-IS or a 250 or something like that, you can process these other cameras in that workflow as well. Now, we don't have the photogrammetry workflow. You're not going to go make 3D point cloud, do SFM, that sort of thing. But we do support full PPK processing. That's free. It doesn't, there's no per minute charge for that or anything like that. But you also have available Trimble RTX. So we've worked with the Planix to get Trimble RTX to work with these DJI sensors. So that's a pretty nice addition to the software base, I think. So let's talk about the performance of the 515 now that we're done talking about software for the moment. Just a quick review of what we mean by precision and accuracy. So accuracy is how close am I getting to what I was aiming at. Here we can see low accuracy in this lower right-hand image, where I've got pretty good fidelity of the shape of the thing I'm modeling, but I'm not in the right spot. So that's accuracy. And then precision is, what is the conformance? How well are the points conforming to the surfaces that you're modeling? It's also often referred to as noise. So here you can see where I'm pretty accurate, so I'm getting all the points in the right place, but there's a lot of noise. They're bouncing around quite a bit. So we talk about those two major characteristics of accuracy when we specify a system. Network accuracy testing can only be done by having something that has been measured independently and can be observed in the data. So it's usually a ground checkpoint or a series of ground checkpoints, and then some tools to measure whatever it is you're measuring. Is it the LiDAR data? Is it the image data? Or is it the combination 3DIS data that you're measuring? These tools are built into TrueView Evo for measuring network accuracy. So let's look at an example project. So this is the first article testing of the 515. We were flying 3 different sensors at 75 meters above ground level. We included all returns and all overlapping flight lines. And this is important when you're looking at accuracy. Make sure you understand what the company or whoever you're speaking to about accuracy. Make sure that you're talking the same basic situation. So here we've not said, let's go look at a single flight line instead of putting them together, because things get worse when you put together overlapping flight lines. A little bit of drift in GNSS and so forth, and it's going to show up in accuracy. But that's the real world. So we really want you to see the real world results. If you go fly these sensors, you have normal overlapping flight lines and so forth, depending on what your project needs are. What kind of results can you expect? We used ASPRS compliant triangulated irregular network surface probing. So this is in compliance with the 3D accuracy specs of ASPRS. And let's go from left to right. So we have the Premier 620 on the right. This is the RIEGL base system with an APX20. And we have a network accuracy measured in root mean squared error of 1.6 centimeters. That's just remarkable. It almost seems to violate physics. You can see that the mean error here is 7 millimeters. So we really had, it's quite often you'll have bias in LiDAR data. In this case, we didn't on this particular flight. Over on the right, we have a mislabeled sensor. This should really be the I copied some incorrect data in, I should say. Here in the middle of this view, we have the TrueView 515. Here we do have a bit of bias. So we've got 1.6 centimeters of bias, which is not terrible, but bias can be removed if you've got checkpoints. And there are tools within TrueView Evo to debias LiDAR data. And we've got a root mean squared error of 3.1 centimeters. So this is for the TrueView 515. Quite nice. This is very nice for a sensor of this class flying at 75 meters AGL. Now I've got this mislabeled on the right, but this is a TrueView 410 flown over the same area. And again, we have very low bias in the TrueView 410 with a root mean squared error of 3.5 centimeters. So that's quite nice results for the 410. Now the interesting thing to note about the TrueView 515 is that the standard deviation here is 2.7 centimeters. And that gives me an idea of what the accuracy of this sensor would be if I were to do debiasing of the data. And that means to subtract this mean error out of the data, a common practice. So if we look across the board, if we sweep across here, then we see that the standard deviation on the REDEFINING class system is 1.4 centimeters, 2.7 centimeters on the TrueView 515, and then 3.4 centimeters on the 410. So this is quite remarkable for the 515. You know, we're getting really good accuracy with a 32 beam sensor. Let's talk about precision. Now, precision is how much, if I fly on a hard surface, how much deviation am I getting from that hard, flat surface? So in the top, we have the TrueView 620. Again, this is the RIEGL Mini Vux with an APX 20. And of course, this is one of the prime reasons to get a RIEGL. Just look how quiet that data is. I mean, this is remarkable. The grid that we're looking at is a 10 centimeter by 10 centimeter grid. Very, very, very little noise in the RIEGL data. Next, we have the TrueView 515. And you can see we're peak to peak of not much over 10 centimeters. That's amazingly low noise for a 32 channel sensor. And then the TrueView 410, we've got a noise envelope similar to the 515. Although I noticed when I was processing this data that this one could use a bit of a calibration tweak. I'm showing by return, and so you can see that the yellow return is slightly lower than the, or not by return, I'm sorry, but by flight line, and you can see the flight line represented by the yellow points a little bit below the cyan point. So we could improve that a bit on the 410. But the important thing to note is that it looks awfully good for all three sensors, and we actually, so you know, that's heuristic. I'm just looking at peak to peak, but we do have tools to quantify it, and it's important to quantify precision or noise. And remember, noise is measured different than network accuracy. In noise, I look at the spread of the data. It's going to be Gaussian. I figure out what one standard deviation is, and that's the spec I give. So here's what spread would look like. And if you look in a profile view, you'll see the entire spread. But remember, the spec always looks less than the spread you see because we talk about one standard deviation. So here we have this for the 620, the 515, and the 410. Where in the 620, we have a density 80 points per square meter and a precision of 1.6 centimeters. Just remarkable. You know, of course, that's a RIEGL class system. That's what we expect from those sensors. Very, very quiet sensor. Range of only 11 centimeters in that data set. On the TrueView 410 here at the bottom, 275 points per meter squared with a precision of 4.2 centimeters. So you can see we're under that advertised, you know, we advertise 5 centimeters maximum noise in this sensor, and we're easily achieving that. And then here with the 515, 395 points per meter squared. So we're really saturating the ground with points. We've got one standard deviation at 3.4 centimeters and a total range of 17 centimeters over that entire sample set. Pretty remarkable. That's tight. That's tight data. So what about sensitivity? We don't have a really good way in the industry right now to measure this. Martin Flood and I have been having a lot of discussions about how can we quantify sensitivity. Right now, all you can do is look and see how well it detects the stuff you want to detect. So here we've looked at some wires, and these are kind of between, you know, they're distribution wires, but it's three-phase distribution, but it's not 43,000 volt stuff. You know, it's probably it's probably 8.3 kilovolt type line. So you would see that going down a city street, etc. So TrueView 620 at the top, excellent detection. Look how low that noise is. The data looks thin, but that's just because we're zoomed out on it. And of course, the 620 is a lower frequency scanner than these others. If you look at the bottom image, the TrueView 410, then you see that, yeah, I've got a few wire hits. And so if I brought this down below 75 meters, I'd start picking these wires up. And we tell you guys with the 410, you know, this is not the best system for wires. And that was really the big driver for the 515, because you came back and you said, well, you know, in a year, my business is going to be developed enough for me to go into the 600 class system, but that, you know, I can't get there right now, and I need a solution for wires, and the 515 fits that perfectly. Just look at that wire density that we're seeing. This is from 75 meters distribution class wires. So you can see this is going to work just fantastic for this kind of application. How about ground penetration? That's the other big thing we're interested in. If I'm in a vegetated area, how many points am I getting on the ground? And I tell you, I would have liked a little bit denser vegetation to go do this with. So we use some dense piney woods because that's what we had for vegetation in Alabama right now. And we compared the three. So again, in the top view, you see the RIEGL with 20 points. Well, and what I did is I took these 75 meter flights and I classified a patch of ground in the middle of these piney woods. And I repeated that for all three sensors. So it's an identical test area, same flight pattern, everything for these three sensors. And this density means what was my density of points that were classified to ground. I just ran an automatic ground classification. I did no editing. And so with the 620, I've got 20 points per meter of ground density classified. You never need more than that. That's a lot of points on the ground. If we drop down to the TrueView 410, it's doing pretty darn good. We got 15 points per meter ground density with the 410. But look at the TrueView 515 here in the middle, where we've got 43 points per square meter in ground density. And check out this, how nice this profile is. Nice continuous stretch of ground here. And this is where our little joke and tipping our hat to our Australian partners comes in with Vegemite. So this is the mighty vegetation sensor, we think. I've got a chart, a decision matrix. I'm not going to read through this, but it'll be available in the slides when we give them to you. It's a work in progress. Any feedback and your opinion on it is greatly appreciated. But it just tells you, hey, from this family of sensors that you guys offer in this 3D imaging ensemble, what's the right sensor for the kind of work that I need to do? And I've tried to give an indication based on common things like hard surface or coal pile, et cetera. And then one at the bottom I call DOT expectations. What does the Department of Transportation expect you to have? They expect you to have a RIEGL. So that's over here. Business discussion. So this is where I hand it over to Madeline. So thanks very much, and I hope you found that informative.
Thanks, Lewis. Give me just a second. Okay, Lewis, let me know when you can see my screen.
I can hear you and I can see your screen.
Perfect. All right, well, thanks everyone for joining us. So if you've been following us for a while, you'll know the objective of GeoCue is to bring the best technology to market at a value that exceeds the price. We're excited to bring the 515 to market with the same concepts in mind. Now that Lewis has presented the technical case for acquiring a sensor, I'll focus on the items included with our system, as well as the cost of becoming operational. We offer our TrueView 515 system under two business models: a traditional purchase model, providing companies with 3D imaging system and software that Lewis highlighted today. We also offer the system under a subscription model, allowing users the ability to utilize a system for periods beginning at 1 month. I'll talk more on the value of these business models as I go along. So let's dive into the packaging of our systems. When purchasing or subscribing to our TrueView 515 system, you'll receive the components appearing on my slide. The main sensor unit. This includes the Pandar XT32 with fully integrated dual 20 megapixel mapping cameras and the APX15 position and orientation system. A control box for quick visual indicators when the system is ready for operation, antenna kit, memory synchronization unit for quick data transfer from the LiDAR and cameras to a computer, 2 batteries with roughly 90 minutes of flying time, a battery charger, case, and 2 days of virtual training. The standard purchase and subscription model both include licenses of TrueView Evo, PausPack, and our TrueView portal. With a purchase unit, you'll receive a desktop version of PausPack, and with our subscription units, you'll process your PausPack data in the cloud. TrueView Evo is a core piece of software for end-to-end point cloud processing. Because we developed this software ourselves, it gives us the ability to understand the industry's needs and build tools around it. We look to streamline workflows like integrating PausPack directly into TrueView Evo, eliminating the need to jump between various software tools. Our aim is to provide a full solution and a one-stop shop. At GeoCue, we offer virtual training sessions each month for our customers. We break up the training into 2 sessions. The first day covering pre-flight and mission planning all the way through colorization of the point cloud. The second day covers topics like classification and exporting a DIM. I've shared the upcoming dates on this slide. Please let us know if you need to reserve a spot. Outside of the provided kit, You'll need to select an airframe to mount the TrueView system on. We try to keep things simple when selecting an airframe. The TrueView 515 will mount to any platform capable of carrying the 2.2 kilogram payload. You'll also want to ensure the landing gear will not obstruct the view of the sensors during flight. Our most common integration is on the M600 Pro, and we now have an integration for the newly released M300. With a subscription unit, we include the mount for either system at no additional cost. For a purchase system, a mount can be acquired for $950. If you opt to mount the TrueView on an alternative platform, we can provide integration on a consulting basis. We've integrated on numerous platforms to date. At GeoCue, we offer a wide variety of additional products that might be of interest to you. We're an enterprise DJI distributor, reseller of the DRS Drone Rescue System Parachute. We also offer base station and rover kits through iGauge, as well as customizable training and consulting services. Through our partnership and integration of the Applanix hardware in our system, we offer several different positioning options. Our recommended setup is using a physical base station on site. Other services include SmartBase and PPRTX. These can be utilized as needed, and fees are assessed by the minutes of flying time. So now we'll cover cost associated with getting started. Very competitively priced, our TrueView 515 is available at $75,000. This includes the LiDAR and cameras, software, and 2 days of training. It does not include the drone or base station equipment. New with the introduction of the 515, we'll be partnering with a finance company who can characterize the purchase of a unit over 36 months. These rates will likely not be as good as the bank, but will offer flexibility if this is the route you look to go in. The first year of hardware and software maintenance is included with the purchase system, and out-year maintenance on the system is $15,000. Next, we'll cover our popular subscription option, also offered on the TrueView 515. All of our subscription units include 500 minutes of flying time in a month's period. This allows for operations of greater than 1,000 acres in a month's time. If you exceed the amount of time, additional minutes can be purchased. Our subscription offering starts at 1 month, priced just below $8,000. Our most popular option on the subscription system is typically a 3-month option, giving users ample time to conduct internal training on the system prior to deployment on a project site. The 3-month offering is priced at $17,000. The subscription system includes sensors, software, a mounting bracket for the M600 or M300, and 2 days of virtual training. Maintenance for the systems are included in the pricing, and all systems are kept up to date with respect to firmware and calibration. Through our flexible offerings, our aim is to make drone LiDAR affordable for a variety of business cases. Since our release of the TrueView system in 2019, we've watched companies grow out of our subscription model and into purchase systems. We have companies with more work than single systems can support, creating a need for multiple systems. This is reassuring for us at GeoCue. Our technology is meeting the demands of our customers and providing models to which they can grow. If you're considering where to begin with drone LiDAR, a few points of consideration. The subscription offering is risk-free. If you have clients who are interested in seeing the data from a drone LiDAR system, our 1 or 3 month subscription is a great place to start. Even better if you can line multiple projects up during the duration of the period. This is a great option for customers that have seasonality to their business. If you're looking to purchase a system, obviously I'm biased, but I can't stress enough the value of selecting a TrueView system. GeoCue has an interesting place in today's market. Unlike most other suppliers of hardware, our background is software. We sell our software to companies who've previously acquired LiDAR systems from other vendors. We understand the complex part of drone LiDAR is not in operating it, but it's in processing the data after it's been collected. Because we've wrapped our own software around our system, we've worked hard to streamline this for users lacking experience with processing data of this type. Another key factor for selecting a TrueView system is our tightly integrated camera LiDAR configuration that Lewis showed examples of today. We didn't want to be another supplier of off-the-shelf camera and LiDAR, collecting data independently of one another. We considered the value of having both components working together, and it really shows when you look at our data. We're excited about the TrueView 515, and we believe it'll redefine the market for this class of sensors, offering companies quality data at an affordable price. So give us a call or send us an email to discuss the system in greater detail, and we'll be happy to share sample data with you upon request. So with that, I'll conclude my portion of the presentation. Thanks for joining me, and I'll hand it over to you now, Martin, for questions.
Excellent. Thank you, Madeline. You guys hearing me?
Yes, we
I can
are.
hear you.
Perfect. Well, Q&A. I thought I was getting the easy job today, manning the Q&A desk, but you guys have kept me busy. We have had a lot of questions. So we'll get through what we can here in the few minutes, and then we'll wrap up. Crystal has a poll that we'll run at the end. First, just general, because a few people ask, as you always do, we are making a recording, or we are recording this webinar, and you'll get a link in the next day or two, so you can review that recording or share it with your colleagues. So there will be a recording available for that. And again, we have so many questions here today. I am going to have to just pick and choose a few that I think might be of most interest to the audience. Any we don't get to, we will respond to you via email. So Lewis, a couple of questions about calibration, specifically for the LiDAR. How often do you need to do a calibration? How is calibration handled in the TrueView ecosystem? Can you maybe speak a little bit to that?
Sure. So we don't know is the bottom line answer. So we've had sensors that have been, of course, we have quite a few that are owned sensors. We've had TrueView 410s on the market for more than a year. And other than, say, hard landing, like really hard landing, we haven't really had to do any recalibrations as of yet. Now, the nice thing about calibration is that if we do have to do a calibration for you, we'll tell you a flight pattern to fly. You'll send us the data that's sent to us via TrueView Reckon. We do the calibration and post those calibration results back to Reckon, and the next time you fly, you're automatically using the new calibration. So no sending the sensor back or anything like that. It's quite easy. So I guess all I can answer right now is, heuristically, the calibration holds up quite well as long as the sensor isn't, pretty violently jarred around or something of that nature. It's easy to keep an eye on it. And if you have any questions at all, you can send us a screenshot and we can say, yeah, that looks like a calibration could be in order.
Okay, excellent. I had a couple of questions. I think you did touch on this in the presentation, but perhaps you can just go back over it in terms of ortho photo generation from the oblique imageries. How is that handled within TrueView Evo?
We don't handle that in TrueView Evo. We rely on third-party structure from motion software to do that. We've integrated very tightly with Agisoft Metashape because they have a Python driver kit with their software. We're integrated from a parameter point of view quite tightly with Pix4D. We have a number of customers that use the context capture. So we would go into those workflows for that kind of work and then back into TrueView Evo. We do have, I won't go into it at this point, Martin, but we do have some special tools integrated with Metashape that let you create orthos in environments where that's usually somewhat difficult, that is high vegetation, that sort of thing.
Good, excellent. I'll talk to this one. We had a couple of people asking about field of view of the LiDAR. So keep in mind that the 515 and the 410 are 360-degree scanners. That is, those LiDAR subsystems are scanning 360 degrees. Of course, you're flying this on a drone, so you're really interested in just, the nadir look or view of that. So the system does scan that, but of course, you want to limit what you're going to collect in that field of view. You can open that up. You could go as much as plus or minus 60 or even a little bit larger. Eventually, of course, you'll run into issues with the drone platform. But keep in mind, this is LiDAR. So the further off nadir you go, you can start to have some issues in terms of accuracy. Our recommended best practice is you keep the LiDAR field of view to plus minus 45 degrees, so about 90 degrees, a little bit smaller than the camera field of view, and even a little bit tighter than that if you can practically on your project. So generally, plus minus 45 degrees is the maximum we recommend for the LiDAR field of view. Another quick one here, I'll just comment on a couple of people asked about training. As Madeline mentioned, we do include 2 days of training with a purchase or a rental of the system. That training covers essentially the sensor operations. We obviously assume that you have trained pilots on staff for doing the actual flying, and that you have a background in survey. You know how to set up a base station. But with those 2 days of training, most people are comfortable going out and doing their first few projects, and we tend to see that within 2-3 projects, 2-3 sets of flights, most people are getting fairly comfortable into a comfort zone where they can competently go out and collect data. So we think that 2 days of training is what's needed to get you up and flying with a TrueView system. Lewis, perhaps a question for you. There was a question the one we always get: is there a camera only version of TrueView? Did we lose Lewis?
Lewis, you might be muted.
Sorry about that. Can you hear me okay now?
Yeah, we can hear you fine.
Yeah, so the much delayed TrueView 250 hopefully is coming to market in March. It's a dual camera system that's the same cameras used in the 3D imaging sensors, same oblique fields of view. Will mount on the M200 and M300 DJI platforms.
Great, thanks. And actually, this is a question for you, Madeline. A couple of people have asking. I know you had this on your slide, but platforms that the TrueView can go on. We showed a lot of pictures on the M300. We've talked about the M600, but there are other systems that we can fly on, correct?
Correct. Yep. So as long as the system can carry the 2.2 kilogram payload and the landing gear does not obstruct the view of the sensors, the TrueView 515 should be able to integrate on it. I mentioned the M600 Pro and M300. Those typically are our most popular options.
Right. And we also have seen a lot of folks using, I think, Harris Aerial, Inspired Flight. As Madeline said, essentially, if it can carry the weight of the system, then we should be able to integrate that with you. So we'll have one more question before we toss it back to Crystal for the final poll. Yeah, and I guess I'll toss this to you, Lewis. Just hyperspectral data. Have we done any work with that? And are there any plans in the future for working with that?
Send me an email, please, direct who's ever asking that question, or I'll communicate with you. We're very interested in that. We fly on a totally different project. We've flown a lot of flights with the Altum 6-band. You either call it a 5 or 6-band sensor. And I'm really looking for an excuse of integrating that with LiDAR data.
Excellent, thank you. All right, so I'm just going to toss it back here to Crystal. You guys have been great. The questions are still coming in. As I said, we will get to you all via email, but thanks again for that. It's been a really active crowd, and that always makes these things exciting for us too. So with that, I'll toss it back to Crystal to wrap us up.
All right, well, I just want to say thank you again to Lewis, Madeline, and Martin for this webinar today. I think it was very informative and exciting for a new launch of a TrueView system. So right now I'm going to go ahead and launch our last poll question. And it's simply, what is your interest in the TrueView systems? If the TrueView doesn't fit your needs, please feel free to email us at info@geocue.com with further detail. We'd love to discuss. And I'll go ahead and leave this poll question open. Again, thank you everyone for attending our webinar today. We hope you continue to stay healthy and safe. Again, this webinar has been recorded and will be distributed to everyone registered. Thank you for joining us, and we hope to hear from you soon.